Hello everyone, this is Professor Keene, and this is the third in a series of lectures for Introduction to Astronomy at Wisconsin Lutheran College. Now, since you were young, you probably took science classes, and in some of those science classes, you probably saw pictures or posters that your teacher had hanging up in your classroom, which depicted the sun, the star at the center of our solar system, surrounded by 9 or 8 planets, depending on how late you took your class. In any case, by the planets, which are riding around the sun on these semicircular orbits. This is called the heliocentric worldview, or the sun-centered worldview, that we really inherited from Copernicus, who wrote a book called On the Revolutions of the Heavenly Spheres in 1543. We'll be later on looking at this work by Copernicus, but the point I'd like to make right now is that although this is the picture that you've seen hanging up in science classrooms all over the country since you were young, the fact is no one has taken a picture that looks even remotely like that. That is, what you're looking at is an artist's conception of our solar system. There have been no satellites, I repeat, that have gone outside of our solar system, aimed their camera back, and taken a picture that looks even remotely like those kinds of pictures that you see in posters or in science textbooks. So the question is, how did man arrive at that kind of perspective of the solar system? After all, 99% of the data we have, to minimize it, at least 99% of the data we have, is based on observations of the motion of the sun, the moon, the stars, and the planets from standing right here on planet Earth. And from that perspective, we are taking a geocentric worldview, at least for the sake of pragmatism. When we look up at the sky, it seems like we are sitting still and the sky is orbiting around us. While the ancients saw this as the actual worldview, even modern astronomers take this as just a pragmatic way of approaching astronomy. The nice thing about Stellarium, the software package we're looking at, is it allows us to adopt this geocentric worldview. That is, it allows us to look at how the sky looks from our perspective here on Earth. And remember, the idea is the Earth, we're standing on the Earth, and we imagine a celestial sphere, a huge globe rotating around the Earth once per day. And on this globe are pasted, so to speak, or fixed or stuck, the countless stars, moon, planets, and sun that we see rising in the east and setting in the west every day. So what we're doing is we're looking at Stellarium. Stellarium provides us a way of doing stargazing from the comfort of our own home to get a sense of the way that the sky actually appears to move on a day-to-day basis. In the lecture that we just completed, the second lecture, we talked about how the sun appears to rise in the east, travel across the southern part of the sky, and set in the west day after day. And yet the path it takes across the sky is different from day to day. So let's continue that discussion and talk in a little bit more detail about the path of the sun across the sky. I'm going to open up Stellarium software. Okay, and right now I'm viewing on August 24th of 2020, and it is right now 3:45 in the afternoon. Let me click on some of these shortcuts to make our grid appear. Okay, again, these are effectively the latitude and longitude lines. These lines right here, I guess we would call these the longitude lines on the celestial sphere. These are actually lines of what are called right ascension. On the celestial sphere, they're not called longitude lines, they're called lines of right ascension. These lines right here are called, we would call these the latitude lines if they were on the Earth, but on the celestial sphere, they're called lines of declination. And the idea is that if we turn off the atmosphere, you can see all these stars, and these stars are fixed at various lines of right ascension and declination, just as cities on the surface of the Earth can be located at lines of longitude and latitude. Okay, let's bring the atmosphere back, and we're looking directly toward the south. Once again, if we turn around and look toward the north, now we're looking at the pole of this celestial sphere that once again is rotating around us. So just get a sense of the way this works. Let's make it go quickly, and you can see that entire celestial sphere rotating around us once every day. If I click right here, I'll go back to the present time like that, and let's go back to real time. Okay, now let's go back and look at the western part of the sky. So you can see here that the sun rose in the east, it's traveling, it's riding on this huge sphere around us, and it's going to set in the west in a few hours. Okay, let's go back in time and look at the sun as it's crossing our local meridian. So first, open up the sky and viewing options. Let's click on markings and look at the meridian line. Close that, and so when we look toward the south, this green vertical line here is our local meridian. And now I'm going to go back in time until the sun is passing that meridian, and I'll stop it right there. Okay, so that looks like it passed our local meridian right around, I'll open the date and time window, right around 12:53, 12:54, around there, okay? And once again, it is August 24th right now. Now, when we ended our last lecture, we talked about how if we take a snapshot of the southern part of the sky right around local noon, that is right around 12:54 or so each day, and we look at where the sun is in the sky day after day after day, we'll notice that it passes the meridian at different altitudes or different angles above the horizon from day to day. So notice these lines right here of declination. 0 degrees is the celestial equator. Once again, if you think about this enormous celestial sphere orbiting around us or spinning around us, that is equator or the waistband of the celestial sphere. It's 90 degrees from the poles of the celestial sphere. The sun right now is about 11 or 12 degrees above the equator, and notice that celestial equator is about 5, 10, 15, 20, 25, 30, 35, 40, 45 degrees above our horizon while we're here in Wauwatosa, Wisconsin. Okay, now let's look over the course of the next few days what happens to the position of the sun across this meridian right around noon. So on the 25th, 26th, 27th, 28th, oops, and let me get the constellation art here so we can see what's going on and the labels of the constellations as well. So as we go on August 30th, 31st, and we move into September, notice that the sun is moving downward. That is, on successive days right around local noon, it's going to be at shorter or smaller altitudes above the horizon. Okay? As we get to September 22nd, notice that the sun is now right at 0 degrees declination. That means it, whereas in the previous days it was in the northern half of the celestial sphere, at this point it's crossing into the southern half of the celestial sphere. That day, as I mentioned in the last lecture, is a special day. It is called the Autumnal Equinox. It's the day that the sun moved from the northern to the southern half of the celestial sphere. Let's continue forward in time. November 29th, 30th, September. Now we're in October 9th. The sun is moving down through the hand of Virgo. October 22nd. Now we're entering November. It's still going down. Still going down into Libra and Scorpio. We now enter December, and we're approaching December. Oh, let's go back a couple of days. I saw something interesting. It looks like on December 14th, the moon will be passing nearly in front of the sun, so there will be at least a partial solar eclipse on December 14th. We'll have to keep our eyes open for that. December 16, 17, 18, 19, 20, 21. And notice now that the sun in its downward descent has slowed down and come to a stop. The sun has come to a standstill. That is called a solstice. This particular day is the winter solstice, December 21st or 22nd, depending on the year. It is when it is in its lowest altitude above the horizon. Notice it's only 5, 10, 15, 22 or so degrees above the horizon on December 21st. That is, it's going to be rising in the southeast, kind of hugging the southern horizon, going up to a maximum height of about 22 degrees above the horizon, and then setting in the southwest on this day. Okay, let's continue forward, and as we move forward, now we're January 1st, the sun has moved to Sagittarius, now it's moving to Capricorn in January, it's moving to Aquarius in February, and it's moving upward, 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 March, and notice now on this date, March 20th of this year, the sun now at local noon is going from the southern half of the celestial sphere up into the northern half of the celestial sphere. That is, it's crossing this celestial equator at 0 degrees declination. And right now it's in Pisces. Okay? That day, by the way, March 20th or 21st, right around that day, is called the vernal equinox. Let's continue forward. I'm going to look up a little higher in the sky because the sun is going to go up. March, we're now in April. It's going up, up. In May, it's entering Aries. Let's go up a little higher. And now it's in Taurus. And now we're going into June. Notice it's slowing down and it reaches its highest altitude right around June 21st or June 22nd. That's when it has the highest angle above the horizon at local noon. That day is a special day. It is called the summer solstice because the sun is standing still in a sense before it turns around and goes back downward in the sky. Okay? And now as we continue through June, notice that on the subsequent days at local noon, it's getting farther and farther south, August, and now we are at September, and we are right around September 22nd, and now we are back to the autumnal equinox where the sun is passing through this 0 degree celestial equator. So we've gone through the entire course of a year and pointed out that the sun at local noon is passing through different altitudes above the horizon throughout the year. On the winter solstice, it's really very close to the horizon. On the summer solstice, it's very far from the horizon. It's interesting to note, by the way, that the sun is in front of different constellations on different months of the year. Although there are constellations that cover this entire celestial sphere, something like 80 constellations or 88 constellations, there are 12 particular constellations that are special because those are the constellations in front of which the sun is passing throughout the course of the year. So I'm going to open up my sky and viewing options and mark something called the ecliptic. That's a red line, and you see right here this red line. That red line passes through 12 particular constellations. I'm going to run through these so you can see what they are quickly. We're in September. The sun is in front of Virgo. As we move on, October, it's still in front of Virgo, but by the time you're in November, it's now in front of Libra. Now, as we're entering December, it's in front of Scorpio. Then, as you're entering January, it's in front of Sagittarius. Then, by the time you get to February, it's in front of Capricorn. And by March, it is most of the way through Aquarius. And in March, it is in Pisces. Then as we're entering April, it's still in Pisces. But by the end of April, it's entering Aries. By May 1st, it's entering Taurus, the bull. In June, it's approaching Gemini. And by the end of June, it's in the middle of Gemini. Beginning of July, mid-July, it's in Cancer. By August, it's making its way into Leo. And then notice it's going back by September, going back into Virgo. Those 12 constellations make up what we call the signs of the zodiac. They are very important constellations because the sun will be in front of one of these signs over the entire course of the year. That is, it moves through all 12 of these signs over the course of the year. It's also important to note that the sun, when the sun is in front of a particular sign, that is when it's in front of the constellation Virgo, that constellation will not be visible in the sky. Why is that? Well, when the sun is in front of it, it's very bright and you don't see those stars in that constellation. So for example, I was born in July 18th, and so my sign is Cancer. That means the sun was in front of the crab Cancer around the time that I was born. So Cancer would be up with the sun and Cancer would not be visible. On the other hand, Capricorn, which is on the opposite side of the zodiac from Cancer, would be up around midnight on the month that I was born. Okay, so that is a brief introduction to how the sun moves through the signs of the zodiac over the course of the year. I can't emphasize how important this is to understand this geocentric worldview, at least for practical purposes in understanding stargazing. And that worldview consists of this. It seems from our perspective that we, standing on Earth, are at the center of a huge celestial sphere. This celestial sphere is orbiting around the Earth once per day. The stars that make up the constellations that we see appear to be fixed to this celestial sphere. They rise and set as this sphere rotates around us. The sun also rises and sets every day of the year, but over the course of the year, it wanders through the constellations so that whereas one month it might be in front of Leo, the next month it would be in front of Virgo, the next month it would be in front of Libra, it makes its way, it wanders through 12 constellations of the zodiac over the course of an entire year. Okay, why don't we stop there and we will continue this discussion next time.